Alright, today we're going to talk about an infamous subject, which is exercise induced muscle cramping. How does it happen? Why does it happen? Well, what is exercise associated muscle cramping, or EAMC? Basic exercise associated muscle cramping has been defined as painful, spasmodic, and involuntary contractions of skeletal muscle that occurs during or immediately after exercise. So one of the first theories was the electrolyte depletion and dehydration hypothesis, and that began with over 100 years ago. Basically, miners were reporting cramping, and these miners were exposed to high heat and were profusely sweating. So these early anecdotal observations led to the development of the traditional electrolyte depletion and dehydration hypothesis for exercise-associated muscle cramping. And that has stayed all the way till today as being one of the dominant theories. However, Sulzer sort of changed things here and out of Tim Noakes' lab, and as you know, Tim Noakes has sort of changed some ways in which we've thought, and this is very controversial, but basically they saw that in Ironman athletes, they compared Ironman athletes and their potassium and sodium levels between crampers and non-crampers, crampers being gray, the non-crampers being the blue. Basically, you notice there's no significant difference in potassium or sodium. So this didn't really support the electrolyte hypothesis. Also, if you look at the total amount of mass lost, which is an indicator of clearly dehydration, there's no difference between the control and the cramping condition. So hydration status was indifferent, electrolyte status was indifferent, yet they still cramped. What's going on there? Now, one of the things I want to point out is this. If you have altered serum osmolarity and altered serum electrolyte concentrations, specifically hypochloremia, hyponatremia, hypercalcemia, this can cause generalized skeletal muscle cramping at rest in specific clinical settings. So if you actually do have a drastic drop in electrolytes, your whole body will cramp. You'll have whole body cramps. Okay? But if we're looking at the clinical picture of exercise-associated muscle cramping, the majority of the cases are localized cramping. Okay, that indicates not an electrolyte imbalance. And it doesn't support the electrolyte depletion hypothesis. And in fact, data from well-conducted prospect cohort studies show that athletes with acute exercise-associated muscle cramping are not hyponatremic, hypochloremic, and hypocalcemic, and do not have an abnormal serum osmolarity. So one of the newest thoughts and mechanisms is a neurological mechanism resulting from an altered reflex control mechanism in response to muscle fatigue. Basically, exercise cramps are associated with poor conditioning. Okay, so if someone is poorly conditioned, their probability of having exercise cramp goes up. Like if you came off, you say you're working with a football player, a high school football player, and in the preseason, cramps are very high. Why? Especially and they're now training in a hot environment as compared to their home. Well, what's happening is that they're poorly conditioned, so they're going to cramp. Notice also that cramps occur in the second half of a race or event. They occur more frequently at higher intensities, and people who run faster race times have a greater frequency of cramping. This all leads to the fatigue hypothesis of cramping. That fatigue results in neural changes which lead to cramping. Now, it is true that if you consume carbohydrates in an electrolyte drink, that'll delay the onset of cramping, which you can see here. Carbs plus fluid result in a longer time to take to cramp as compared to the control. But one thing I'll point out is given that the crampers only lost 500 mils of fluid, it's unlikely that this occurred because of dehydration or lost sodium. But rather, the drink probably delayed fatigue. and therefore cramping, if cramping is a measure of fatigue. So why does this occur? Well, when you have fatigue, like 50 to 60% declines in force, this results in increased spindle fiber sensitivity. Those are the fibers associated with stretch, and decreases Golgi tendon activity, and that's your inhibitory activity. So you have greater excitability from the increased spindle fiber activation or sensitivity, and a decreased ability to inhibit force when tension is ramped up. The result is cramping. If you look here, what you're seeing is that the cramping muscle has higher EMG activity than the non-cramping muscle. Again, this indicates a neural effect. Now, one thing we know is that stretching activates Golgi tendon organ and relieves cramps. This suggests that it is a neural mechanism. So, summary: cramping related to exercise does not appear to be an issue of dehydration or electrolyte balance, unless you're experiencing whole body cramps. If the person or the athlete is experiencing whole body cramps, especially in environments like Florida, then it's possible that, in fact, it's likely that it's a dehydration or electrolyte issue. But if it's localized fatigue, again, go back to that football player. If they're cramping in their hamstrings, well, that's where a lot of their power is coming from. It was localized fatigue. So basically, fatigue results in hypersensitivity of spindle fibers and desensitization of Golgi tendon apparatus. The result, if fatigue continues, is elevated muscle activity and cramping in the working muscles. So basically, if you want to avoid cramping, you need to delay fatigue. And that comes from superior conditioning as well as nutrition, which delays fatigue. And that's what we see here. Consuming a carbohydrate electrolyte-containing drink appears to delay the onset of cramps, likely due to decrease in fatigue and perhaps by modulating central drive. Finally, the most effective treatment for cramps is stretching the cramp muscle out, which is likely mediated through activation of the Golgi tendon apparatus. That's the end of the lecture. I'll see you next time.